What is going on, everyone? Today I am going to talk a lot about the circuit design that I'm going for, making this Super-Puss and bringing it to life. So, just to recap, this is the 1998 NAMM display unit of the Super-Puss, and George and Way Huge only made four actual functioning ones of this, and this is the fifth chassis, and it was empty insides. But obviously, I'm starting to work on it. But there was knobs and everything, which I do have. I'm going to reuse. Um, so I am commissioned to bring this to life for the customer, and that's that. But I sort of really want to do this pedal justice and figure out what the heck is going on in the circuit inside. Now, in order to start doing that, and the main reason why I think I was a attractive selection when it came to stepping up to the challenge from all the techs out there is I've done an extensive amount of research on what George did to convert a Boss DM2 into what we now know as the Aqua-Puss. I'm gonna guess that he started in 1996 designing the original Aqua-Puss, just because of when these things started hitting shelves, when the QC stickers on the inside. But basically, I'm not going to focus on what the changes were from a DM2 to this pedal, because there are differences between the AP2 and the AP1 and the AP2. So here on the right hand side is a 1998 Aqua-Puss, and the circuit's a little different. So I'm going to focus on what the changes are from a Boss DM2 to this, because again, the 1998. So I'm going to go ahead. This was fact checked in QC checked in 1998, and why that's important is because that's when NAMM was going on, and the fact that NAMM was the reveal of the Super-Puss. I think it's a pretty good start to look at the circuit inside here and see what the differences are between a Boss DM2 and the Aqua-Puss. So we'll come back to the component selection in a little bit. I just want to start talking about the differences. So over here, I have some components, and on the screen, I'm going to share with you just kind of a list of the changes that George did back then, between the Boss DM2 and the Aqua-Puss. Now this is my schematic. Definitely if you have a 4K screen, it's the best view angle, but I am going to show over here the list of changes. Now ultimately it looks like a lot of changes, but it really comes down to component selection, more or less, and not a change in the circuit. So keep that in mind. The major change in the circuit is eliminating the flip-flop, or basically it's the buffered bypass part of the pedal. So George was very, very good at making these pedals sound great and be tour duty because of the careful, close attention to the enclosure and the switches and the circuit itself to make it sound great. So basically eliminate the flip-flop or the buffered bypass, and you can see the signal then travels through here. Any one of these 1 microfarad coupling caps, and the purpose of that coupling cap is to block DC from basically one part of the circuit to the next part of the circuit, and I'm kind of showing that here on the screen. Component selection wise, so he's changed these transistors over to MPSA 18s, and here's a bunch of those coupling capacitors that I talked about. This particular capacitor was changed from 0.1, so this is probably the only major deviation besides the coupling capacitors that he made. And I don't know if it makes a big tonal difference, but this will change the bottom end. Basically, the roll-off, if you have a capacitor and the signal goes directly through it, the response of that capacitor, the larger the capacitance, the better bass response is. Or sorry, not better bass response, that's subjective, but the more bass that will be present and preserved through that signal. So some pedal builders will specifically, like especially over here, because you see like the input to this circuit, we'll choose like 0.022 or 0.027 or 0.047 in this example. So there's quite a bit of bass, but it does roll off just a little bit for, for various reasons. Some pedals might sound muddy if there's too much bass and things like that. So more or less that's what's going on here on that part of the circuit. So those were changed over to MPSA 18s, and then the op amp themselves. So there's one here and here. Those were JRC 4558s. They were changed over to LF353Ns. So kind of interesting. It's a little bit more of a wider bandwidth op amp, which in theory, can preserve the top end a little bit more, better performance, blah, 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 more than the 4558. So more or less in the discovery of what's going on between a Boss DM2 and the Aqua-Puss back in 1998, that's what you got. Not much. So as the circuits I've observed from George's creations back then, as the circuits became more complicated, the less and less was changed. So here is the actual schematic from the Boss DM, no, sorry, not Boss, Electro Harmonix Deluxe Memory Man. And not any Deluxe Memory Man, but the version that has the MN3005 chips in it. So if you look at the controls of the Super-Puss, you have mix, tone, modulation, delay, feedback, and then you have a chorus and vibe thing going on. Very much reminiscent of a Deluxe Memory Man, right? The biggest difference is that instead of a gain or level, you have a tone knob. So I'm going to have to take a guess on where that is in the circuit, and you're going to see that soon. So again, getting in the mindset of what would George do in 1998, designing basically an analog tape delay simulator is, it looks like pretty much standard operating procedure for him was changing out op amps and turning them into LF353Ns. So I'm going to change all these out to LF353Ns. Just because the owner and I agreed on a price, I'm not going to redesign the circuit board or design a circuit board specific for the Super-Puss. So I am using the Mad Bean Total Recall circuit boards. And one of the exercises I did was to make sure that the schematic, the original schematic with all of the bipolar, basically all the coupling capacitors in here are bipolar, which means it's going to block DC, well, anything above. So you have the sine wave that kind of comes straight across. Look at this one here. So we have a sine wave that comes up, pretend like this is ground reference. It goes up, sine wave comes up and back. Well, this reverse polarity, or basically negative polarity, it puts a lot of stress on the electrolytic capacitors. So one way to prevent that from happening, flowing electrons going back and forth, is to have a capacitor going basically the other way to keep that signal happy on the other side. In theory, that's going to make a better signal continuity, a little bit more hi-fi, or actually just basically preserve this original incoming signal a little bit better. Does it sound better? I don't know. That's subjective. But that's just something kind of geeky to think about. Now, on the Total Recall circuit board, I had to pay attention to this. All the non-polarized or bipolar coupling capacitors have been changed into a single 1 microfarad film capacitor. Now, that's an awesome choice. Absolutely awesome choice. And nice and compact. But the problem is that's not going to cut it for what I'm going for, which is what would George do in 1998. So I strongly believe, and you can see that there's a couple examples around here, that the capacitors that are in these spots, so like here's a 1 microfarad, just like the Boss DM2, he was always up, basically increasing the capacitance of these from 1 microfarad to 10 microfarad, just like on the Boss DM2, he did a similar thing. So there's also, I believe, well, I don't think there's too many of them actually, but this one down here is a 4.7 microfarad that I believe he also would have changed to 10 microfarad. And I think this makes sense too, because if you're a company and you're buying capacitors in bulk, you're likely going to want to standardize some components in areas that just may not make a difference. So those are some of the things that I'm thinking of that he did. The one area that I'm not going to change is this particular C33 down here. And that is, I'm going to keep that a film capacitor just because I don't think at this particular spot is important. And plus, I'm not quite sure which way the capacitor should go, plus or minus on either side. So I think it's a safe bet. It's not a critical area for tone. So I'm just going to change basically 1, 2, and 3 out with electrolytics at 10 UF. So making it a little bit more true to the original. Otherwise, this particular circuit from Madbean is spot on to the original. Now, what are some other things that George might do? Well, you know, component selection wise, I think is important to talk about at this point. And inside, remember, 1998, we see a lot of carbon film resistors, and we see very, very few. Here, I'll give a little close up. Some carbon film resistors and some metal film. These metal films are very high sort of resistance. So I'm going to say that, you know, in theory too, if you read your electrical engineering books, the higher the resistance, the more noise can be introduced to the circuit. And in theory, the metal film resistors are lower noise. Now, whether or not George was thinking that back then, I'm not sure. We didn't have a direct conversation about that. But I'm going to guess, you know, it doesn't hurt to have that approach. Now, carbon film are in theory, going to be a little bit less expensive to find back then. So production costs are going to be a little bit better. These capacitors, again, this has never been modified. Actually, it's never been opened. I'm the first person to open this pedal after it was closed in 1998. These are really nice. I don't know if they're NPO grade, and that means basically the temperature, as the temperature increases of these capacitors, they're going to remain stable at the same capacitance over a broader temperature range. Because if you get a cheap capacitor and you're playing out in the sun, you might notice, especially if you have like transistors for like fuzzes and stuff, the temperature does make a difference in your pedal. At room temperature, they're not going to matter too much. But if you play outside in the sun and whatnot, that could make a little change, and an unwelcomed one at that, depending. Over here, it looks like these are Panasonic polyester metal, metallized polyester capacitors. And I'm going to also use very similar components in mine. So here's the circuit board that I came up with. Component selection, just talking about that briefly. You see like these yellow caps, the same company that's made those. And in here, these orange ones are actually made by Philips. In the original in the original Aqua-Puss, the AP1, the selection was BC or Philips polyester film capacitors. So I was able to find the same type, or basically made by the same factory, but they're now orange, and these are discontinued. So I'm going with a little bit of NOS beauty in this. As you can see, there's a few pads. So see, this square pad is now changed out with a electrolytic capacitor, and these are the 10 UF microfarads I was talking about. So in the conversion from a Boss DM2 into the what we now know as the AP2 Aqua-Puss, I'm doing the same thing. So converting the Deluxe Memory Man into what I think is going to be the Super-Puss circuit. And if you recall the forum entry of someone who had actually one of the 4 functioning Super-Pusses cloned, the technician just said that there was a few capacitors changed, and that was basically about it. So component selection, I'm doing mostly carbon film. You see these tan resistors, those are mostly carbon film. and the higher, like 1 meg or 910K and above, are metal film, just to, you know, I don't know. It might be like what is going on over here in that component selection. The capacitors, those tiny capacitors, you see some blue ones, just like in the Aqua-Puss over here, those little blue capacitor and that one over there. I believe that those are really nice, high quality capacitors at lower values. So like in the picofarad and very, very low, like single digit nanofarad. And you're going to see some of those right here. So this looks a lot like that guy over here. That's ultimately component selection wise what's going on here. I want to talk a little bit about the only other changes that I'm making here, and this is possibly what was being interpreted as this is a capacitor change. So here's the analog man clock change. This is extending the clock. So the term, and it's not appropriate, it begins with an R in the car world. When you turn the timing down, I don't know. I think I'll get flagged if I say it. But it's a kind of unpopular term nowadays. But you basically slow down the timing, and that's what this particular circuit did. It wasn't really extending the full delay of the MN3005 chips. It is slowed down on purpose. So Analog Man came up with adding 400, or basically a 47 picofarad capacitor in parallel. And what that does, you see it over here, in parallel, that's actually going to make that capacitor 300-ish picofarad, which will extend the clock to more around, so from 550 milliseconds to about 600 milliseconds. It's not like a huge one, but I think that's actually what George would have done, is increase that clock. Because on the Aqua-Puss, especially this one, the clock was extended out from the standard to around, 330, 360 milliseconds. So I think he is pushing the clock a little bit harder on here, which may or may not, well, actually it will create a little bit more distortion on the repeats with that change. So I'm going to make that change here. And then another important thing that Analog Man does, which I'm going to implement here, and you can see this trim pot, is basically this trim pot of the input gain resistor. So I'm going to change, I basically took that resistor and made it a variable resistor using this trim pot. That's going to do the same thing. Now for the tone part of the circuit. So if you recall, there is a tone knob on the Super-Puss. I think I'm going to do that right here. So this is the wet signal coming out. Studying the Super-Puss that was reissued in, well, actually it was made, I don't even think it's a reissue. I think it's a fresh circuit. In 2012, there was a tone knob, and that tone knob controls how dark the repeats are. And I think that was basically a nod from the original. So what do I think is happening there? I think this is what I'm going to come up with. I'm going to try a 100K pot. I'm going to try a 250K pot, and even a 10K pot, dragging the top end frequencies coming out of the wet side of the circuit, because you can see it right before the blend, and pull that high frequencies down and darken the repeats in theory. So this is part of my my own thing here. I'm going to try and see if it achieves the tone that I think is going on. But for the most part, that's everything I kind of got at the moment. So next up is actually assembling the Super-Puss and giving it a listen. I'm pretty close with all my parts coming in. So if you like what you see and curious on what happens next, subscribe, and we're going to have some fun. So, see everyone real soon.